to record, the session. Let me, I hope it is recording. Yes. Okay, it is recording. And let's come here and raise all of these guys. Okay. Last session, I solved one of the three DFS recursive problems, and we saw how we can do the backtracking. And I saw some people in the session, they suggested to have more backtracking problems. That's why today I want to go over two classic backtracking problems. But these problems I want to solve today, backtracking problems. Actually, the backtracking problems is one of the patterns. You have to learn, how to apply the backtracking pattern in the problems. And lots of my students I see, the problems I want to solve today, if you are beginner, they will be really, difficult for you guys. But if you are in the, you are not beginner, you will learn. You know what is the recursive functions, and you solve some recursive, and if you solve some problems using the recursive approach, it will be easy for you. But I saw lots of people struggling with this kind of problem. But if you learn in a correct way, it will be easier for you guys. And actually, the problems I'm solving, the meetups, there are, you can find the solutions. You can find on the web the solutions. You can find, the lots of videos, educational videos on the web. So there's a question why I'm doing this here. Because the method I'm teaching is different. I don't see, in lots of videos, they only show the code and the solution, and then, go over code and explain the solution. It is like, teaching in the university. When I'm teaching, even, in the university, we put, some slides and, go over, the line by line. We are doing here this, and because we don't have enough time, in the syllabus when we do in the quarter or semester in the university, because we have to cover whole course, whole textbook. I don't have any other, option. I have to go in that way. And lots of videos are, the style is in this way, actually. They have the solution, and then they start, explaining that. But the reason I'm doing these meetups, I want to show you how I'm thinking. I want to show you a step-by-step of the thinking process to find the solution. And I think this is a different part of, my teaching for coding interviews, because, as I said, there are solutions on the web, and you can check them. But we don't want to learn only one problem. My purpose is to teach how we are approaching the problem, how we are attacking the problem and find the solution. If you learn the strategic way, how we are solving, by learning one problem, you can solve lots of problems, problems similar to that problem. And that's why I'm not selecting any problem for the meetups. I'm selecting some problems that are pattern. You can use them as a basic problem and map that solution to lots of problems that you can map with this pattern. And today I want to go first. I want to go to the 8 queens or n queens problem, which is one of the classic problems in computer science. And at first, it looks really complicated problem, and it is nightmare for lots of, my students and lots of, even software engineers. But if you learn once in a correct way, it will be easy for you forever. And you will be able to solve lots of other problems using this pattern. So what is the n queens problem? Maybe all of you guys know the problem, but I want to go over the problem definition really fast, and to be sure all of you guys are know the definitions of the problem. Let's say we have a chessboard. we have a chessboard. So we have, let's say, in the standard chessboard, we have 8 rows and 8 columns. Eight rows and eight columns. And we have 8 queens. We have 8 queens. Oh. And we want to set 8 queens inside of, place 8 queens in this chessboard. And what is the objective? Objective is they don't cross each other. They don't attack each other. I want to go by one examples here, and you will see, and we know that the queen, if you have a queen, goes, the movements of the queen is horizontal, vertical, and diagonal. I assume, all you guys, know this, the definitions of the queen. So let's say I want to go in do one example, one placement of 8 queens, one valid placement of 8 queens here, and you will see, there may be some difficulties of the solution of the this problem. So let's go. I want to put 0, 1, 2, 3, 4, 5, 6, 7. We have indices here. So let's say I want to put the first one here. If I put the queen here, I know that all of these cells will be invalid. I cannot put any queen in the same row of the queen and same column. Also, the diagonal. So with the first selection, I selected first one. I want to go only one simple example, and so you will see what's the challenges. So we put the queue, and I put with the with this with the X for all the cells that are not invalid for the next queens. And so we did the first row. For the second row, I want to put another queen. So let's say I want to put here. And again, I will have all of these guys invalid, 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 and invalid. Okay, I go over vertical, horizontal, and diagonal. So we did the second row. The third row, I want to go over, let's say we did here, let me. So we've started with the 5, okay. And let's say I have this option, right? I want to select the 6. And all of these guys will be invalid, invalid. Actually, I want to go with this diagonal, X, X, and X here. Okay, we did the third row, and let's go for the next one. Let's say I want to select 0, the column 0, and I will select these guys, 0, X, X, X. In the next row, which one I can select? I have 2 options, right? 2 and 7. I have 2 and 7. Let's say I'm selecting 2. I'm selecting 2, and these guys will be gone as invalid. And for the 5, I have only 4. Only this cell will be invalid. For 8, actually for row 6, I have I can select this one, and this will be invalid, and the final one will be this. Okay, This is one of the correct emplacement of 8 queens, and they don't attack each other, right? So, and I want to write, the outputs, one of the correct placements. I can use one 2-dimension matrix to show, let's say, all of these 0, 0, 0, 0, and Q here, right? Or 1 here. I can show in this way what is the correct displacement. But I want to use a better way. I want to use one-dimension array, which is with the length of 8. Let's say I want to put here, the queens. The queens is a one array or one list. And the index 0 means the row 0, I want to put the index of the Q or queen. I will write here 5. I want to only decrease, the output format. In lots of, I saw the in lead code or, the other places, they return 2-dimension array, but I want to return only 1-dimension array. But I changed the definition of this. The row 0, I put in the column 5. In row 1, I put the queen in column 3. And then 6, 0, 2, 4, 1, and 7. This is one of the answers, okay? This is one of the placements. What is the question? Definitely we don't have one answer, right? We have, more than one answers. And the question is return all answers. So I'm repeating again, the problem definition. We have 8 queens. We have a chessboard, a standard chessboard with 8 rows and 8 columns. We want to place queens inside of the chessboard, and they don't attack each other. They don't, kill each other actually. And so, and we are sure that we have more than one placement, valid placement, and we want to return all valid placements. And it will be, let's say the result should be a list of lists. And we know right now, we know that one of them is this guy, and I did in random at first, right? And we will have more placements. Any questions so far? If you have any question, please ask, because I saw some people, they are, it is a little difficult for, some people to understand, the format of the output. We say that these are queens, but the index means row number, and the value is the column we put the queen, okay? And in this way, we are decreasing actually the size of our output. Okay, let me check the chat. We don't have any question in chat. Okay, let's go. So you saw how I did, in the first row, I selected one column as to place my queen. How many candidates I have for first row? For the first row, I have 8 candidates, right? I can put Q here, 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 because it is empty. I want to go over, the how I'm thinking, and then I will convert my thinking process, my thinking, and all of my decision makings to algorithm. Okay, so how I'm doing it here, let's say this is empty. I want to let's say all of these guys. Actually, maybe it will be better to go to the next slide. Yeah, I don't need here. So let's say I have, again, let me do this really fast. So I want to go row by row and put my queens, place my queens here. So how many options I have for the first row? 8. 8 options I have because we don't have, let's say I put my queen here. So all of these guys will be disabled, right? And these guys will be disabled. Also, all of these guys will be disabled. So for the second row, how many options I have? 6. So let's say I put here. I don't want to go all of them, you know, the second row is enough. So if I put here, these guys will be valid, and these guys will be valid, and these guys will be. How many options I have for the second, you know, the third row? I have 3 options. As you can see, how I'm doing all of my decision makings. For the first row, for each row, I have some valid columns, as you can see. For each row, I have some valid columns, considering all of the previous queens we placed already, okay? For example, I put it here, and right now for the row 3, I have only 3 valid options. So it means that when I'm going row by row, for each row, I have some options, right? I have some options. I can put my, place my queen, and I have to check if it is valid or not. So I need is valid function. This is one of the functions I need to have before placing my queen. And also, I have some options for each row. Let's say I'm in row number I. My row is I. And for each row, I have some options. In the worst case, I have 8 options, right, in the first row. So it means that I can select 0, I can select 1, I can select 2, and actually the column 0, column 1, column 2, 3, and column 7. And when you are thinking about the problem and you have some options for decision making, it should remind you recursive solutions. Recursive. Why? Because all of these guys can see as a sub-problem. If I select 0 for the remaining rows, I have similar problem to place my queens. If I select 1, with if I place my queen in the column 1, for the remaining rows, I have same problem to solve. So it means that for each row, we have, in the worst case, 8 sub-problems. But all of these sub-problems are not valid. I need to check is valid using is valid function. I need, before calling all of these guys. For example, here in the row number 3, I don't need to put in all of them my queen. I have only 3 rows. So number of my sub-problems, valid sub-problems, are 3, not 8. So, so far we figured out that I have more than 2 sub-problems. In the worst case, I have 8 sub-problems. If I put my queen here, I can solve the remaining of this chessboard using this similar function. That's why I'm saying this is recursive, because the signature will be the same. If I put here, I have another problem. If I put here, I have another problem. But how can I call this problem? I need to have some knowledge from the previous rows. That's why we have to have some data structures to save all of the previous actions which is the placement of the previous queens. That's why we have an array named queen, and initially it will be none, or it can be -1. Let me put this -1 to make it more for all languages can be -1. It means that we didn't place any queen in any column, right? So it means that in row 0, we didn't place anyone. Let's say I put all of these 3 rows. Whenever I do this, I have to update my queens. So let's say for this problem, the 0 will be 0, and row number 1 is 4. I will put this here, 4, and then for the next row, I have to pass for my recursive call for this subproblem, starting with row number 2, this queens, because based on this queens, this information, I know how I did before. And these are 2 main steps to detect. You need to have a recursive solution, and then in order to be able to write your recursive solution, which extra information you need, because for this this function, let's say the queens, we don't have any the inputs, right? The initial value in the top level, we will say place queens, and everyone knows we have 8 rows and 8 columns, right? But in order to formulate our recursive function, as you can see, we need row number, queens array, and also we need result array, because we will add the queens whenever we reach the end of this, the chessboard, we will add the queens inside the result. So based on this, you will detect what will be signature of your recursive function. Let's say I'm writing here place queens. The first step is to detect you need recursive. How you will detect it? When you are solving the problem manually, you should be a little aware of what you are doing. Whenever if you see you have a decision making between you have different options, it should trigger the recursive solutions, because you have subproblems. So after you understand this, you have to go to the next step. Which information I need? So if I'm in row, let's say row number 3, so it means that I need row number. Also, I need to detect which columns are available. I need the queens array. The queens array. And also in every cycle, I wanna add I need one list of lists, which is empty at first. I wanna append this queens when we reach to the end of the chessboard inside of the results. This is the the approach you can think about this kind of problems. I think it is not that difficult to detect you need to do the recursive solution. Also, detecting which variables I need to pass to my function. Also, if you solve 1 or 3 or 4 problems, you will detect it really easy. So based on this, let's go and write the code. And because we have all the all the information to be able to write the code. I want to go row by row. For each row, I will do a for loop. For each row, I will do a for loop, and I will place my queen in all of the valid places. And then I will call my place queens with row plus 1 and all of these guys, because we update these guys. And this will be the next step. Let's go and write the code, and I think it will be much, tangible for you guys. So let's go, and I want to write a define place queens. I want to write, the row. Actually, I don't want to. We can write even the top level, but I prefer to write, let me write the top level also. Place queens. And I want to define here one queens array, and which is -1 for underscore in range. I'm assuming we have 8 columns for a standard chessboard. So we have this queens because we want to pass this to our recursive function. And we have results, which is empty list at first. And that's it. Let's go and call our recursive call. And also, I think we don't have any return value for the helper, or let's say, I want to write helper. Yeah, helper is better. Helper row, initial row is 0, and then I will pass queens, and then result. And that's it. After this, we can print. Let's say I'm printing results to see all of the answers. But let's raise this because it is only for printing. Okay. But the main function is helper, our helper. Helper, we have row, queens, and results. Like I do this, first I want to go right in the recursive parts, and then I will be back to write the base cases. So I said for each row, we have to have a for loop for whole columns, right? So let's write the code. For column in range 8. My column is going from 0 to 7. And I'm writing if is valid. Let's say we have a function named is valid. In the interviews also, please do this strategy. Let's say, because you have to write first, the top level algorithm, and then you should dive into the details, right? So let's say I have is valid function, which returns me true or false, and I can detect that this column is valid or is available or not for me, right? In this problem, maybe is available is better name, or let's say is valid, right? But in order to be able to detect is valid, I need queens array, definitely, because we have all the information, which columns we put, our queens, right? And also the row and column I want to right now put, right? So if is valid is true, because right now, I want to put, I have a row number, I want to put in this row, and the column in the for loop, I'm going from 0 to 7. At each round for the same row, I'm putting, different columns from 0 to 8, 7. And here I will check if it is valid, go ahead and do the recursive call, right? So if it is valid, I wanna update, I wanna put my queen in this column. How I will do that? I will write queens row will be column, right? It means that, you know, I want to say the queens, the row number, you know, let's say 0, put a number, let's say it is 5. It means that we are putting the queen in the column number 5. And we put this here, and now it's time to do the recursive call for the remaining of our problem. So I will do the helper. My recursive is helper. The next step will be the next row. So that's why I have to increase my row plus 1. And queens, we already updated here, are updated in the previous line. And the result will be updated in base case. But we need to have this because we need to add all of the answers in the results. So now it's time to learn when we need to do the backtracking and why we need backtracking. Let's say I do this and I don't want to do the last line to show you why we need the last line. Now let's go and write the base case. So far I did, you know, the for loop and we did all the recursive calls. I will write the is valid, but let's assume we wrote it already, right? And please follow this method in the interviews. Don't dive into is valid. So here, you know, again, the same approach. We are increasing row. So I need to do upper bound for row. But the queens and results, I cannot check anything. I can check the queens that if all of them are not -1 means I place all of my queens. But the best way is to check the row. If row is 8, it means that we have 0 to 7. If row is 8, it is out of range. And it means that we already placed all the queens. So I will write here if row is equal to 8, it means that we successfully place all the queens here, right? In all the rows. And now the queens is one of the answers. So it's time to add this in the results. In the base cases, usually we return something, but here the output, the return value, our return value is results, and we put in the input arguments. So it is kind of returning something, but because we are appending for all, you know, combinations, we need to append. We don't need to return something. We have to append one of the answers in the results. Because we don't return here, we need to write else here, right? In some simpler, easier questions, we usually write return something here, and we don't need to write else because it is automatically else. But right now we did if, because we don't return, you have to write else for the body of your function. So now it seems everything is true, but there is one important bug here. So when let me check the chat, okay. So for every, you know, let's say this is the body of my recursive call, right? I want to show you how you should detect you need backtracking or not. Inside of the recursive functions, if you call the function for more than once, right? Sometimes we call only once in our the recursive call function. But as you can see here, we call this for 8 times. in the worst case, right? Maybe it is, but in the worst case, let's say all of them is valid. We call 8 times. So if we are doing this, let's say I'm calling the helper, and then again I'm calling the helper, and again I'm calling the helper, right? For different values. Every changes I'm doing before calling my recursive function, I have to revert it before going to the next one, because I don't wanna see the result of, you know, for example, here, I put my queen in the column, you know, in this column, right? And I call this. In the next round, I wanna put my queen in the another column, right? Let's say the first one we put it in the 0, the column is 0. The next round, we put in 1. And I have to revert the previous one because I already changed this. Let me show you here by example. Let's say I put the queen here, and this is the first round of my for loop. And I change, you know, when I put here, you know, I change, you know, my queens to 0 and all of the guys, you know, the -1, right? In the second round of for loop, I want to put only queen here, and then I don't want to have queen here, right? I want to put the queen only in the second column. I want to try that one. In the second round and third round, I want to put the queen here. But if I don't revert my previous change, it seems that I'm putting a queen here, and then here, and then here. And my sub problems will be wrong. That's why after I call this guy, because I want to have another call of this in the next round, every changes I'm doing for all the inputs, I have to revert it. Actually, row, we don't change the same row. We only, you know, increase it. And result is a global variable. It is, it's the scope is, you know, all the recursive calls should update it. But the queens is exactly locally for every, you know, the recursive call. So that's why I have to write the queens row is equal to -1. Because for the second, but next call, I wanna, let's say I'm here, you know, let's say I did, you know, the column number was 1, 2. I put the Q here, the queen in the column number 2. In the next for loop, I wanna put the queen here, but I have to, before putting this here, you know, erase this. And how we are erasing this? By putting the -1. And we name this backtracking, and that's it. It is nothing. It is not, you know, really. I saw lots of people, you know, they're talking about the backtracking, you know, as a nightmare, you know, I don't know. But as you can see, it is really easy to detect it. If you have a recursive function and you are calling your recursive function for more than once, and you have some parameters, variables that should be, you know, they're only locally. They are, you know, their definition is, you know, local to that function. For example, result here is a global variable. As you know, in every recursive call, we're going to append something inside of that. But the queens is not in that way, right? And when I'm updating here, for the second call, I have to revert it. How I can revert it? Like this. I have to put the initial value we defined it here. And that's it. And our, you know, actually our answer, you know, our function is done. You know, this is the 8 queens solution. And the only thing I need to do is to write the isValid function. Another way to bypass the, you know, backtracking, but it is not, you know, optimal way. But in the interviews, if you are struggling with backtracking, you can use this method. Instead of putting the queens here, we can put a copy of this guy. If I copy this, the queens, actually I'm not changing the queens inside of this, okay? If you copy the queens, you don't have any problem. But it will increase your space complexity. It will increase definitely your space complexity, and it is not a good idea. If I copy this queens here to this guy, every changes we will make inside of this will be invisible for the next round, right? That's why, you know, in order to keep the space complexity lower, we don't need to do the copy. Copy actually increase both time complexity and space complexity. If you copy an array, the copy is order of n, and n is size of the array. And also you are creating a new array, which is in terms of the space complexity also is order of n. And there is another bug here. I intentionally do, you know, first, you know, the, you know, really incomplete or, you know, the code to show you what is the common mistakes. So look at here, you know, we append the queens to the result. And as I said, the queens is only one array. What does it mean? It means if I, let's say that the first queens is, the first time we reach to the row 8, let's say the queens is equal to, I'm writing in random. Let me write the, some valid value. Let's say this is 0, 4, 7, 5, 2, 6, 1, 3. The first one. And I'm adding this in the results. So let's say I'm adding this in the results, and this is my result. I add the first one. In the second round, I don't have a new copy of the queens. I'm updating the same queen. Actually, we have one place of the memory which is allocated for queens. And we are updating this, and then we are changing the new queens and adding here. Actually, at the end, you will see how you have all same values here. And what will be them? It will be the last queens, the last valid placement. That's why we have to copy of the queens here. And therefore, copying in Python, you can write a list of queens. We have to copy at the end when we want to add this in the results. I hope, you know, you are understanding, because, you know, these are really advanced topics. And I said, you know, if you are a really beginner, it will be maybe difficult to understand, but it will trigger you to go and study more to understand, you know, more in deep, because these are really advanced topics. Here we have the queens. As I said, the queen is only one place of the memory. Let's say we have a memory and the queens here, right? We put some values here. In the next round, we override it. The next time we override it. The next time we override it. And we are appending these guys here. And in the result, all of them will point one location of the memory. And it will be the last valid queens we found in the. So that's why we have to copy of this. So if you copy this, it will be a new piece of memory. And it's done. And this is our code. And let me write the isValid function. And I strongly, and I urge you to write in this way and don't dive in. Whenever you see, you know, you need a function, go ahead and write it. Write only the signature. And if you have time, you will implement this, because formulating the top level answer is much more important than writing one of the submodules. So for isValid, let's write the code for isValid. Define isValid. And we have queens. We have, you know, the information about all the queens before the current row. if I'm in this row, it means that I have some values for in the queens from 0 to the number row and column. I want to place one queen in row and column, right? We'll say this is a row, this is column, and this is the cell I want to put my queen in this row and this column, right? I know that I have to check if I have, let me write here, the chess, I draw lots for several times the chessboard. So let's say I'm here and row is pointing this way, and I want to put the column here. I want to put one queen here. I want to know if it is valid or not. And we know that we put already some queens in the previous rows. I have to check only these guys, not the next ones, right? Because we go row by row. So how can I check this? I have to check if there is no queen in this column, and also there is no queens in these diagonals, right? And that's it. And I don't need to check the row because we just want to put the first queen in the current row. So how can I do that? I need a for loop from 0 to row -1 to count all of these columns, right? To have access to this. So that's why I'm writing for R in range row. It means that it will go from 0 to row -1. And I want to say the new column. What is the new column? So, and then let me write it in an easier way. If the column, you know, it means this guy is equal to queens R. So it means that we have R and the queens R is this value, right? If I want to put 5 here, for example, right? And I want to check if it is 5 or not. If it is equal to queens of R, it means that my column number is equal to the column number of the previous queens. I have to return false. Return false, right? And how can I check the diagonals? I want to know if there is something here and there's something here. As you can see, the diagonals, the difference of row, let's say I want to check this by this. What is the row? And you know, for this guy, we have 0, 1, 2, 3, 4, 0, 1, 2, 3. So this is 4 and 3, and this guy is 1 and 0. 4 minus 1, the difference of rows should be equal to difference of columns. If they are equal, the differences, I have to return false. Okay? So I have to write here another if statement, and my row is changing from 0, 1, 2, 3, and I'm checking all of these guys. So I will write here the queens. Let me write first the difference of the row minus R. Row is this guy. R is changing from 0 to, and we know that row minus R definitely is positive because row is greater than R. R goes from 0 to row -1. If this is equal to row minus, so we did this. And now we're gonna go to the column minus. So if it is equal to column minus the previous columns, what is the previous column is queens. We know that we save the columns inside of the queens, column minus queens. But I need to have absolute value. I'm not sure it is always positive or not. Okay, it depends on the column number. If row minus 1, the difference of the current cell, difference of the rows is equal to difference of the columns for any of the previous rows, I have to return false because it is in same diagonal. And if I traverse all of them and I don't have any problem, I didn't return any the false value, I have to return true. It means that the current row and column is valid. I can put my queen in this guy. And it's done. And yes, I think we don't have any extra space, extra work for on this. Any question? Let me. I have a simple Python, editor in my iPad. Go ahead.
So where you are checking whether it is in the same row, because the check was checking in the same column, but I didn't find to. So here you are doing if column is equal to queen R. So R is essentially storing the column, right? So where the row check is there?
Yeah, okay. Because, let's say we go row by row, right? We start from 0, 1, and when we are in the new row, we are checking all of the previous rows. As you can see, we go from R to row minus 1, right? If I'm in row number 4, I'm checking all of the rows from 0 to 3. It is not possible to have same row because I go row by row. This is the approach, right? I put in the first round one queen in the first row. The second round I want to put the second row, right? And now I want to check if is it valid to put my queen in the row and column, in the cell of the row and column, but I put only some queens in previous rows.
Oh, okay, I got it.
You got it. Yeah. We go row by row, line by line. Yeah. Okay. Actually, I have a simple and really basic Python interpreter in my iPad, and this is the code actually I right now developed on my my whiteboard. As you can see here, we have the place queens, and in the line 24 I defined none. You can put -1 or none. Actually, in the code I put -1, but in Python we can put none, and it's really easy. And result is empty, and I'm calling my place queens, and at the end I'm resolving. Let's go and check the results. And I'm printing the length of the results. As you can see, we have 92 valid placements. Okay, and as you can see, all the results we have here, all of the valid placements of the queens. For example, the first one says in the first row you have to put the queens in the column 0. The second row put in the column 4, and the third row, you can go and in this way, and you can see all the results. And this is the magic of the recursive solutions. You formulate your recursive functions, and then your function can solve problems that you cannot solve with your brain, with your mind. Okay, and this is really interesting. This is the power of the recursive solutions. The only thing you need to do is to find, first of all, if you need a recursive solution. Let me be back here. If you need a recursive solution and how you can detect it, you should, when you are solving the question manually, you should be aware of all of your decision makings in your mind. You do lots of decision makings in your mind, but you are not really sensitive for them. You are not aware of them. You have to be a little more you have to have a little more awareness to see what you are doing. And then you need to categorize all of your, the thinking process and see, okay, for each row, I have some options to select. For each option, I need to update some variables, some data structures to be able to call the remaining problem as I say the self-similar problems. The recursive, actually, we have a self-similar problem, right? The sub-problem is exactly the signature of the problem is exactly the original problem, only the parameters are changing. And this is the way you can do this. And the reason I solved this in quiz, this is really one of the important patterns. You have to know that. And we have lots of problems which are really similar to this problem. The pattern is a structure is like exactly like this. You have a base case. Let's do that here. You have a base case. In the base case, you do some appending in the result, and in else one you have a for loop always, and it is valid, and you do some recursive calls. This is the structure that we use for lots of problems, and they are really interesting and the practical problems. Any question? I don't want to go really fast. I prefer to have more interactive the sessions. If you have any question, I'm really happy to discuss. Let me check the chat. We don't have anyone in chat. Okay. Okay, good. I hope everyone understood. I think you need to review, but if right now I want to go solve the next problem, and you will see how you can relate these problems to each other. And this is the method you have to I think in everyone, if you are getting ready for interviews, don't dive in lead code. Lead code is a great resource for finding some solutions or doing solving some problems, but it is not really organized, right? You need to have really a good strategy, how I want to learn all the patterns. So that's why the selection of the problems is really important. I'm trying to select really important problems that are the basic problems. They are not necessarily the easy problems. This problem is one of the hard problems of the lead codes. If you go and check it, it is hard, and the success ratio is less than 50%, maybe less than 30%. Okay, but you can use this to solve lots of other problems. I mean, that right now we have almost 1,500 problems in lead code, and every week we have one contest. Every 2 weeks we have another contest. I mean, every week we add in average 6 problems in the lead code. It is increasing, right? And if you dive in that lead code problems, it will be really confusing and struggling, and you will struggle. And it's not a good idea to solve the problems in random. That's why if we select really good selection of the 100, 120 problems. Actually, I do them of 120 problems in my classes. The value of those problems will be almost 600, 700 problems, because you learn based on the patterns, not only solving one single problem. Any question?
So I posted in the chat, but so is the result actually storing multiple answers, and when we reach row equal to 8, that is like one valid answer?
Yeah, actually in result, as you can see in here, we append whenever we reach to the base case, right? We append one of the valid results in the valid queens in the result, right? So it means that results will append all of the valid queens, right? Let's do one maybe in order to make it more tangible for you, maybe for you guys. Now, actually, let's say we have the queens is empty at first, right? all of them are -1. And the result also is empty. And when, in the first round, we call 8 recursive calls. I don't, recommend to do this, but you need to do for 1 or 2 times to see how the recursive calls are, solving the problem. But after you learn this, you don't need to dive in, to go inside of recursive calls. And for all of these guys, let's say we have, the 0 and all of the -1s. It means, that we put, the first queen in the column 0, or let's say the first queen we put 1, all of them -1, 1, and 2 actually, 3, 4. The remaining numbers actually are -1 because I don't, we are not changing them. 5, 6, 7, right? And again, the next round, actually results also is empty. We don't change the results, right? Result is empty for all. And then we call here, some other sub-problems. We call some other sub-problems, right? And we don't know how many, because depending on which cell you selected in the previous row, previous rows, you will have, the less choices in the next rows. And you will have all of these guys. And this is, the first, let me write here. This is the first row. And this row, this level will be second row. And you will have all of these guys. At the end, you will get the last row, right? The last row, will be 8. I started from, let me write 0. I want to follow the index numbers. 0, 1, and the last one is 7. When we reach to the 8, we append the queens inside of the list. When we reach, let's say we reach the last, this level, and we have a recursive call here, and the row is 8, then it is 7, and the next round we are calling the 8. And we are here in the base case. We append the queens that we carry with us, right? We carry the queens with us, and queens has all the, the numbers valid. And we add at the end, actually here we add results that append in the base case, in the queens, right? This is the way, but I don't, if, as I said, you didn't solve, some, even basic recursive problems, you need to do this 1 or 2, but not for this problem. For example, for Fibonacci, for really basic problems to see how the recursive is, doing the job. But after you learn that, you don't need to do all of these guys. You can do as I did here. You are thinking the high level. I need a for loop. I need is valid to check, and I will update the queen. It means I'm putting, placing some queen, and then I will call the same function for the remaining problem, right? For the it will be my sub problem, and then based on these variables, you will detect what will be your base cases. Any other question? Actually, and also, you saw here, the result is, a list of lists. Actually, I printed this, row by row. If I print, the whole results, it will be list of lists. But, I did this, to have readable answers here. Okay. Let's go and solve the next problem, which is really interesting problem, and